So now at this point, another thing you want to start discussing with the customer is understanding their NetFlow enablement within their environment. NetFlow, again, is a feature that's enabled on various router switches and firewalls. Because the router switches and firewalls are responsible to send us the NetFlow as it's generated, we call these devices exporters. So we need to, early on, and it may not happen on the kickoff call, but shortly thereafter, hopefully we've left them at least with a task for them to provide us information about the types of devices that we can expect to get NetFlow from. So we'd like to understand what the list of those devices are by IP address, device model, et cetera, so that we understand as that data starts to come in, we can validate we are seeing data from all of those devices and that we're not missing any data. If we do not validate that we're seeing all of the flow that was expected and the customer just assumes that the data is there, we may have blind spots in our network, unanticipated blind spots in our network. Now, during this process and during the NetFlow enablement process, you may be required, and depending on your statement of work, whether or not that's written in there or not, you may be required to assist in some of this process. Some organizations already have NetFlow enabled. Some organizations do not and may need some help. So you may have to perform some configuration reviews for various exporters out there to make sure that they know what they need to do to enable this and send us the data that's required. Do remember, as you see in the final bullet here, that touching all of these routers and enabling NetFlow, especially in environments where NetFlow is not currently enabled, very likely requires one or more change controls because they are touching production devices on the network. Because of this, make sure that the customer's aware of it and that they plan far enough ahead. Again, don't plan your on-site until you have NetFlow that you know is inbound. Otherwise, you're going to get through your configuration of your appliances and have nothing to do because there'll be no data. Again, this is all about that planning and the fact that even though we're not in the path and we're not creating any invasive issues, we're not deploying a security measure that's going to prevent connectivity on the network, there are configuration changes that may be required in the network. And again, configuration change says change control. So let's review a little bit here as well at the front end of the presentation about what type of information NetFlow can provide. Again, so NetFlow is a way for us to see the connectivity on the network. In this case, we have an IP address on the left-hand side, 10.183, communicating across various switches and routers to other resources, whether it's the internet or another internal server. Now, the routers and switches on the network that are NetFlow capable will see these packets, and as a result of them passing the packets to the appropriate destination, can also, with NetFlow enabled, store some of this information and then eventually provide it to us for analysis. Now, these NetFlow records that are generated as a result of these conversations going through the NetFlow enabled routers or exporters track numerous different fields. Some of the common ones are here displayed on the screen, whether it's the source and destination IP addresses, various port numbers, the interfaces that were transitioned both inbound and outbound, but a lot of other information as well, whether it's application name that may have come from NBAR that was enabled on that device, next hop, information, certainly TCP flags, but it could even be things like TrustSec SGTs, right, the secure group tags. So there's a lot of information that can be gathered outside of some of the general information. Additionally, some things you don't see here, certainly the number of packets, number of bytes, that all is gathered as well. Now, our goal, again, is to take this information so that we have a record of the conversations occurring on the network. Simply that visibility alone can be invaluable to an organization when troubleshooting different types of security and networking anomalies or trouble tickets. But beyond that, we can do additional things with this data that we'll talk about later by creating baselines and then looking for anomalies based on the baselines that were previously created. Now, there's a couple things I want to review for those of you that are not familiar or as familiar with NetFlow. We're going to specifically talk about NetFlow version 9 and flexible NetFlow, where you define your own record. And I'll show you some configurations of that as well as we move forward. But before we get into the configurations, I want you to understand a couple concepts that are going to be critical. The first one I want to talk about here is that there are typically 7 key fields. The data is stored on the flow collector as it's received from the exporter. that information is going to be all of the data that you're going to view within our solution. But before it gets to the flow collector, it is on the exporter itself, the router, switch, or firewall. Now, the router, switch, or firewall, as it sees every packet come in, is responsible for determining if this particular new packet that just came inbound on one of my interfaces, is this packet part of a continuation of an existing flow that I'm already tracking in a local NetFlow table? Or is this part of a new flow? Do I need to generate a new record in my local NetFlow cache on this router? Now, like any other database or any other table tracking system, typically there are keys to help us determine uniqueness. This is the same thing that we do with NetFlow. So the router, switch, or firewall looks at the packet that comes in and uses 7 key fields to determine if this is a unique record that needs to be created or part of an existing record. All 7 key fields must match on the new packet that came inbound to anything that we're already tracking. If all 7 key fields match, then that information will be appended or added to the record that we're already tracking. Again, if any one or multiple fields don't match, we create a new record for tracking. It's all about making sure that each connection on the network that is a new, unique, individual type of connection for a different purpose is tracked independently. So we have 7 key fields for that. Source and destination IP address and source and destination port number, pretty straightforward. Number 5, the layer 3 protocol type, could be TCP, UDP, IGMP, GRE, ICMP, etc. Number 6 is the type of service byte. If you're not familiar with the TOS byte also includes IP precedence information, so some QoS type markings. And then number 7, what interface did this come inbound on this router, switch, or firewall? So what is the input interface, the logical interface? So if you look at this, the 7 key fields, numbers 1 through 6 come from the packet header itself, comes from the actual packet. Number 7 comes from the device that is the exporter, right? What interface did this come inbound on? Now, if I'm talking from one IP to some other IP and all of these things match and another packet comes in, all 7 fields match, I just take the new information from that new packet, the number of bytes, etc., and I increment my counters on the existing flow I've been tracking. However, if any of this information changes, maybe that same source IP is now communicating to the same destination IP but on a different port. Maybe it's a multi-surface server that has both a web server and an email server deployed. Because some of the information is going to change on that packet, we will track it independently as a different flow. Now, at some point, you should be asking yourself, okay, what do I do with this data, or what does the router, rather, do with this data at this point? Because remember, the router, switch, or firewall is tracking this locally in their own memory space, in their own cache. Well, at some point, we want it to be exported. We want it to be sent to us, and there are 4 ways that this occurs. So the first way, number 1 here, is at the end of a flow. So for TCP-based conversations, we have flags that will tell us within the protocol itself when a flow is ending. So if we ever see a TCP conversation that we've been monitoring, and now a new packet comes in that has the reset or fin flag set, we know, based on how TCP works, that that conversation is ending. So we'll take the data from that particular final packet, we'll put it into the record, and then we'll purge that record from memory, but take that data that we just purged and send it off. We'll report it up to the flow collector. So we will export it based on the fact that that conversation ended. We also have 2 timeouts that we can leverage. The first timeout, number 2 here, is the inactive timeout. Now, by default, this is set to 15 seconds in Cisco iOS devices. This does not need to be modified. 15 seconds is perfect. Basically, what the inactive timeout does is it says if you are tracking a record and you have not seen a new packet for 15 or more seconds, we're going to make an assumption that this particular flow is now inactive. We're going to purge it from memory to make room for more tracking, but we're going to take that data, that record we just purged, and we're going to send that information up. We're going to export it to the collector. Now, UDP is a very common place this occurs because we don't have flags to tell us when the conversation ends. So at the end of a UDP conversation, we'll wait 15 seconds and send the information. However, this could happen in TCP as well. Think about a complex network where maybe there's an outage and a routing change occurs. I was, as a router, potentially in the path for a portion of the conversation, but mid-conversation, the packets are now going and taking a different path through the network. I may just never see the final portions of that conversation. I don't want to keep this record open forever. because I may never see the reset or fin flag. So at the end of 15 seconds of inactivity, I will export the data that I have about that flow to the collector. The collector will take that in from multiple locations or devices that have seen this conversation and stitch it all together. The other timeout, number 3 here, is the active timeout. Now, by default, this is critical, by default, the active timeout on Cisco devices and most devices is set to 30 minutes. This is far too long for real-time analysis. We need you to configure this down to 1 minute, and depending on the platform you're working in, whether it's iOS-based or Nexus and what version you're in, et cetera, this could say your parameter of your configuration may say 60 as in 60 seconds, or maybe the number 1 is in 1 minute. So just again, pay attention to your configuration and make sure you're setting this appropriately. But we want the active timeout to be set to 1 minute. So what is the active timeout? Well, the active timeout says, if I've been monitoring a flow and I continue to see packets inbound from the same source destination, same 7 key fields, I'm going to continue to track that flow locally in the router. But let's say this person was streaming a movie. I don't want to wait an hour and a half before I see this finally terminate and go dormant before I tell someone in the network that an hour and a half worth of data was on the network. So what I want to do is tell them in 1 minute increments. The active timeout allows us to do that. So the active timeout basically is a way for the system to say, if you've been tracking a flow and the gap between the first packet and the current packet, the start time and end time is a minute, we're going to go ahead and purge that record, take that 1 minute time slice worth of data and forward it or export it up to the collector so it can begin to interpret that data on 1 minute bounds. When the next packet came in, which was a continuation of that same conversation, that will just create a new record. Again, at the end of that next 1 minute, it will forward it up to the collector. The collector is intelligent enough to stitch this together. So at first, this collector will only know about 1 minute worth of data, and then we'll learn a second minute, third minute, fourth minute, et cetera. Again, this is critical. Think about a security stance here where potentially someone is broken into your SQL database and stolen or is in the process of stealing terabytes of patient data from your SQL database. We don't want to wait until it's all gone before we tell you. We want to tell you in 1 minute increments that a connection is occurring that may be undesirable. The fourth one off to the right here is if the cache is full. Now the router, switch, and firewall, when NetFlow is enabled by default, does have a default cache size, which quite often does not need to be modified. It's an amount of memory that has been allocated to this table for tracking this type of information. If that ever does fill up with active flows, by default, the device will typically take the oldest record and export it immediately to make room for tracking new flows. Again, numbers 1, 2, and 3 are very common. They're going to happen normally every day as flow tracking occurs on your exporters. Number 4 is much less common. It may happen in very, very busy environments or in the core of the network where you may have an enormous amount of flow data being tracked. So let's look a little bit about flow configuration. Specifically here, I'm going to take you through an iOS-based flexible NetFlow configuration. Certainly, if you're performing this on another platform, the configuration commands will vary, but the language and the types of components you configure should translate platform to platform. So here we have 4 steps. The first 2 are labeled 1A and 1B. The reason they're both 1A, step 1 is because they're both global commands and they can happen in either order. You could actually configure B before A or A before B. It really won't matter. So the first thing we're going to talk about here with 1A is configuring the exporter. Fundamentally, in a global command for a router, we would want to tell it where do we want to eventually, when we have flow data, send the flow information. In our world, that's the flow collector. So the command is simple. It's flow exporter, and then give it a name here. It's my-exporter. And then nested below the flow exporter that we've named, we enable or we enter the destination 1111. That happens to be the IP address of our collector. Certainly, you probably don't have any environments as simple of an IP scheme as that, but the destination will be the IP address of your flow collector that is going to interpret this information. We also want to configure the flow record. Now, the flow record is simply defined as flow record and give it a name, and it'll be a combination of match and collect parameters. Now, this is abbreviated here. On the next slide, I will show you a full flow record. We would expect to see 7 match parameters. Those are the key fields, and then any other number of collect parameters that we require to collect the data that's interesting to us from the network. And again, I will show you what a full flow record looks like on the next slide. Once we have our exporter and flow record configured, we then are going to join them in to the flow monitor. So the flow monitor is basically just taking those 2 components and putting them together so that we have one element to work with on an interface by interface basis. So here you can see that we have flow monitor, give it a name, and we enter and tell it what exporter and what record should be part of that flow monitor. And then finally, we apply this configuration to interfaces. Until we apply it to interfaces, even though we have the global commands and NetFlow configured centrally on the router, switch, or firewall, until we apply it to an interface, we will not begin to collect flow records. Here, we're applying it to interface gig01, and the command simply is IP flow monitor, the monitor name, input. Now, as a best practice, you should try to deploy NetFlow inbound or ingress whenever possible. That all has to do with order of operations and how packet processing is done on Cisco devices. So again, always use input. The only reason ever to go back to output packet tracking, there's a couple fringe cases. Sometimes it's interface-based, such as tunnel interfaces. Sometimes you'll want to do input and output on the same interface. If you're looking at peer-to-peer on an edge switch, as an example, where you may not hit the layer 3 VLAN interface and you want to make sure you're seeing everything in and out, there's a couple fringe cases. But as a general rule, make sure you start with input on all interfaces on the device, not just a single interface, but all interfaces, so that we can track all of the connectivity in any direction. As promised, here is what a full flow record would look like, and you'll notice it's a series of match and collect parameters. Up top, we have our 7 match parameters. These are the keys. This tells the device, don't only collect these, but I want to use this for matching. Is this packet part of an existing flow, or do I need to create a new flow record? If all 7 fields match, then it's part of an existing flow. If one of the fields or more of the fields don't match something I'm tracking, then it's a new record that needs to be created within that router, switch, or firewall. So again, you see our 7 key fields, and then you see a number of other collect parameters here, transport flags, the output interface, number of packets, number of bytes, some timestamps, TTL. There's a lot of information that can be gathered. As a matter of fact, with flexible NetFlow, depending on the platform you're on and the capabilities of that platform, there's anywhere from 70 to 80 up through over 120 different fields that can be gathered, whether it's related to multicast or MPLS or VLAN or MAC address. Again, it's platform specific based on the capabilities of the platform. A couple other configurations I just want to put in the document as a reference. Here's what a configuration of a 3500 X 10 gig E module would look like. You'll notice in the upper left we have a flow record. Some subtle differences in the matching here. We added some fields to match the data link MAC addresses because this is layer 2 and has some layer 2 capabilities. We're also going to use the MAC addresses as part of the matching equation for the source and destination. But you can see overall we're collecting most of the same information, the bytes, byte counts, packet counts, timestamps, etc. We also have our exporter, so we have a record, we have our exporter, we have our flow monitor where we join them together, and you'll also notice on the flow monitor we have our inactive and active timeout set, active timeout to 60 seconds, inactive to 15. And then in this case, you can see that we're applying them to the flow-capable 10 gig module on the 3500X, specifically both inbound and outbound, because this particular platform supports it on the 10 gig E module, but not necessarily on all of the layer 2, pure layer 2 interfaces. So again, in this particular case, we would want to do inbound and outbound tracking. Just as a side note here, we're talking a lot about NetFlow configuration. Some of the guides, there are several guides available on the community site as well as on CCO or on Cisco.com. So there's a lot of information out there for configuring NetFlow based on your platform. So a common search of NetFlow configuration and platform or model that you're looking for will often pull up the configuration guidance for you. Side note here, Cisco ASAs also support NetFlow. It's actually called NCell, in those devices, though. It's not pure NetFlow. NCEL is network security or NetFlow security event logging. It does give you the capability to perform get flow-like information out of these devices. And I would say that definitely is something you want to consider. Don't just get NetFlow from the network devices. If possible, also try to get them from the security platforms. A couple reasons for that. One, it'll tell you when flow denies occur, which could be nice to know if someone's troubleshooting connectivity on the network. Instead of NetFlow losing visibility at the firewall, we have the visibility to tell us whether the firewall passed the packet or denied the packet by policy. Additionally, if you are NATing in the firewall, it gives us the ability to understand that the NAT has occurred so that we can appropriately stitch together the conversation on the pre-NAT IP address to the post-NATed IP address, and we can link those together. Again, everything is done within NetFlow based on IP addresses and IPs that are reported. Having that NAT translation information can be extremely handy. Here's a sample configuration of what NetFlow would look like in an ASA. It's a series of commands, much like what we did in the previous routers and switches. However, it is not NetFlow, it is NCEL, so it's subtly different. Here we basically, at the top of the configuration, define what the environment is that we're interested in monitoring. In this case, we're only going to get NetFlow from the PCI environment, so we're going to generate access lists for this. And then it's a series of class maps and policy maps to determine what flow exports we're going to care about, and then eventually where we send them to. You can see the destination here in the middle of the page is 1010 5010. That one happens to match our specific class map that goes back to our access list for PCI. So any of those PCI flows will be sent over to that particular destination or flow collection engine. A little bit further down, we have a second IP address. This is for everything else. So in this particular case, we're sending some NetFlow to one location and all NetFlow to a different location. So again, within the router switch, firewall, and flexible NetFlow and NCEL, you do have a lot of capabilities to determine where this data goes, whether it's to one solution or multiples. It's not uncommon for customers to maybe purchase Stealthwatch for security capabilities, but maybe they're already leveraging NetFlow for other purposes. Maybe the network team has been using it for other troubleshooting. So they may have multiple solutions that require flow, and because of that, you may see multiple configurations in the router, switches, and firewalls.